this knowledge that's out there is not really represented in, if you get a book at Barnes and Noble about how to program C++ or whatever, it's not going to tell you the right way to do things, because this is like the shadow community of people who have really, figured out how to make programming easier, right? And so there's all these things about how I used to program in the 90s in C that I wouldn't really do anymore, right? So like the abstraction in C and that C++ inherited is like there's the stack and then the heap, and the heap is where all your dynamically created data goes. And anytime you're gonna create something at runtime, it has to go there, and then you get this pointer jungle by default from that approach. And not only are there disadvantages in terms of you know uh, having to think about all these lifetimes of stuff, right? And not only having to think about them, but then um, like I've got some data structure that's full of arrays and strings that needed dynamic allocation. And now I have to go write my function that destroys the data structure and iterates over all those things and destroys them. And that's something C++ tries to do for you, but it always requires some degree of manual intervention. And you just have to like write all that code as well. And in addition to writing it all and making sure it's correct, um, it's actually slow to have all these things on the heap in different places and all that. And so this is one of the things, one of the reasons why functional languages did not reach nirvana as quickly as they expected to.
Welcome to Software Unscripted. I'm your host, Richard Feldman. Today I'm talking with Jonathan Blow, who you might know as the creator of the popular games Braid and The Witness, but he's also the creator of a programming language, which he gave a talk about recently, which he demonstrated some really impressive metaprogramming capabilities. We talk about the design of his language, like why he made the decisions he did, his overall design philosophy, software in general, programming and compilers in general, and all sorts of topics in between. I want to thank everyone who's been supporting Software Unscripted on Patreon. I really, really appreciate it. If you'd like to become a supporter, check out patreon.com/Software Unscripted. And now, my conversation with Jonathan Blow. All right, Jonathan Blow, thanks for joining me.
Hello, thanks for having me around.
And I really appreciate your taking time out of such an important day as Screenshot Saturday to to take the time to chat. So you had a talk recently at LambdaConf, and you demoed a lot of really awesome stuff. This was using the language that you've built to do compile time and runtime metaprogramming, and you showed all sorts of wild tooling like memory profiling and CPU profiling and visualization of like all the ifs in your program. All of this in the program that you'd built in this language. So it's like 300,000 lines of code, like a commercial game. So I'd love to just start with something that's a little bit in the weeds, but one of the things I was wondering is, how do you decide where to draw the line about what is allowed at compile time and not? Like you demonstrated, like you got these messages that come out about like, here's what the compiler just finished doing. It just finished type checking this thing, but we're maybe not completely done with type checking. How do you think about like where to draw the lines around that stuff?
So this actually was an issue, or not an issue. So early on, when I announced this language and gave demos a long time ago, I think the first demo that I gave was in 2013, so not quite 12 years ago. And that would have been, what would you call that? Like, it was not a toy language because it was the predecessor of what it is today, but it was not, it didn't have as rich of a feature set. We were still figuring out the philosophy and all that. But one of the first things that we had was this compile time execution, right? And I demoed that. And the number one criticism that I got from, because, everybody wants to like their language and not like the new thing that you're showing. And the number one criticism was like, oh my God, you're running untrusted code and, you can delete people's hard drive and whatever. And I'm like, yeah, that's what this is. And so that was a decision that I made early on, was that there isn't like a security component to this decision, right? So you're asking about like, what how are the decisions made about what exactly the feature set is of what you can do and all that. And um, there are many reasons why I don't think of it from a security point of view. Like, yes, you can just delete someone's hard drive very easily in this language, but like you already can do that in all the stuff everybody does all the time. Like if you build a C++ program, you've got a makefile necessarily, right? Coordinating the build of that thing. That makefile could do anything, right? And it already can delete your hard drive. It's just more obfuscated or more of a hassle, right? Um, it's just not like Make is one of the worst programming languages ever made, right? But it can do all these things. Um, and then if you're compiling a program, you're going to run it anyway, right? And so what I was trying to get to the bottom of is like what seems to me like unclear thinking about these things. Like, yeah, there obviously if you're running uh if you're running code that you don't trust, that has potential issues, but like you're already doing that. So are you pretending that you're not doing it and all these things? So what I decided early on was the following. I'm not going to worry about any of that stuff. What I'm going to do is find um how much utility is there actually in this idea? How much stuff can you do? How how much easier is it to do it this way than another way or whatever? And just like explore that territory. Because that's one of the valuable things. Like, look, if anytime you make a language or I don't is any kind of project, right? If it's trying out a new idea, that's new information that you're like bringing back to civilization. It's like, look, I did this thing, it worked or it didn't work, and here was the outcome, right? And so at the very minimum, there's that. And then if in the end I decided there is some kind of actual security problem with this methodology, then at least we know what the trade-off is, right? So engineering, I said this in the talk, like toward the end, right? But engineering decisions should be based on a cost benefit analysis at all times, right? Like, should we do thing X? Well, how much does it cost us? And how much do we get for it, right? And then some things will come out positive and some things will come out negative. And um, if you don't know the benefit, you can't do that analysis, right? Like if you say this costs us the following thing, um, a statement of the cost is not enough to tell you the correct decision, right?
Right.
Like you need both sides of the equation. And so that was my attitude early on. And so what it really turned into is there are practical constraints about what this feature set is. And it's mainly because the compiler is just bounded by the complexity of all the features that we're implementing, right? So one thing about a programming language is um, by like the very concept of a programming language is that features interoperate. That's what makes it a powerful language, right? So like, you know, um, I'm going to pick some stupid you could probably think of some nicer functional language features, but like, let's say one feature is like constant expression evaluate. No, one feature is automatically inferring the type of a data structure. Just if you give some anonymous members, it'll like type check that and whatever, right? And another feature is function overloading, where when you're calling a function, you try 5 or 6 different things and that all have the same name, and you pattern match the one that the user wants to call, and then you do that, right? And those two features interoperate. Like you wouldn't want this type inference of an anonymous data structure, or it wouldn't be a very good feature if it was only usable like at top level, and if you passed it as an argument to a function, like that broke
Right.
down, right? But if you're going to pass it as an argument to a function, now the type checking process, right, has to be pretty involved. It has to do this solve of like, hey, this function takes an argument that's the data structure. Does it match this data structure? Well, we don't know because we don't know the type of this thing. So now we have to go into some, you know, recursive or some kind of like, invocation of the type checking system that's not actually related to the function call that we're doing and whatever. Maybe that's too specific of an example for people who aren't super into compilers. But the point is, the thing that makes programming languages powerful is all the features work together. And you like that as a user, but what that also means is in the code, sometimes features don't that naturally work together, and you have to do all this work to like make it happen, right? And that adds complexity to the code. And right now, because we have all these very powerful features, we are bounded by how hard it is to just make the code work correctly in all these cases. And that's probably true for most modern programming languages are like that. It's just the question is, what features have you chosen to spend your complexity budget on? And then how many people do you have working on it? And all these things. For us, we have a very small team. So
Right. That makes sense. Okay, so you had static if. So you had like a pound if at some point in the
yeah.
presentation. It that surprised me because it seemed like, oh, wouldn't that be something where you could just write the if and then that just gets executed at compile time naturally? You talk about like, you're not concerned about security, which makes sense. But I do wonder about the non-security implications of that, specifically around when you're building for a given target, but you're running the build on different host machines. So like, for example,
Yeah.
extreme example of this would be 32 versus 64 bit, and like the pointers are different, so you could get the same code base being built on two different systems, and now you're potentially getting different metaprogramming.
I'll say a general thing first, and then I'll talk about that specific static if case, because I think talking about the specifics is useful. But so in general, when you make a programming language, you've got to like decide what is your overall attitude about making languages, or with what philosophy are you making this language, right? And computer languages have been around 70 years or something now, and so there's been a lot of time for people to develop different philosophies that they have. One philosophy is, and one that I was taught in school, is a language is good when it's maximally orthogonal, right? So if you have a feature that does a certain thing, you don't want anything else that does that thing, right? So orthogonality is a concept from math that sort of means, if you have a vector in one direction, the other vector, the dot product is zero, if you know what that means, right? um, so that's one idea, right? Um, and I think that's a good idea to a decent degree. However, and so it's but I use it more as an aesthetic than a rule, right? It's an aesthetic where if you have a bunch of junk that mostly does the same thing as each other, why do you have all these why are you spending your complexity budget on all these features? I just said these features, or the complexity budget is what's limiting you, right? Okay. On the other hand, uh, another thing that's very important is like when somebody actually sits down to do things with this programming language, um, you want their quality of life to be high, right? You want things to be very smooth and not frictiony and all this stuff. And so the decisions that you make about orthogonality can have a real world impact on that. So for example, let's not talk about any specific thing yet, but like there's some common thing that programmers want to do, and you're like, oh, that's easy. You just do that using this wrapper around this thing, around that wrapper, and it's 9 levels deep of stuff. But it uses this other feature, and it's ugly, but you never have to look at it and whatever. And it's like, okay, maybe, but if you ever step down into that when debugging, you're not going to have a fun time, right? Compile time goes up if you have a lot of things that are like that, right? The size of your executable could go up, or um, I don't know. There's all these things, right?
It's almost always slower
Your
at runtime.
IDE, yeah, your IDE can get more confused. Like whatever it is, there's all kinds. The more code that you have, just that's worse. Like always, right? So these decisions have consequences, is all, right? And so I tend to take that orthogonality principle as an aesthetic, but temper it very heavily by just convenience to the programmer, right? And so let's go to this static if thing, right? Um, and also sometimes it's just like, what is the actual clean way to make these ideas work? So I mentioned we did this first demo a long time ago, and it had compile time execution, but uh, well, that was a good demonstration of the fact that you could do compile time execution in this kind of systems programming environment. It could be fully general. In this demo, I ran a video game at compile time, and like it was a little like Galaga style game, and it would refuse to compile unless you shot at least like 7 aliens. Um, and that was pretty funny. But so that was a proof of concept on a technical level for a certain kind of technical problem. But what I was aware of, right, is the following thing. I have a bunch of experience in C++ and all this stuff, but I used to, when I was in college, I took the infamous scheme class. I did a bunch of other Lisp stuff. I did standard ML of New Jersey and whatever. So like I did Prolog for a little bit, like whatever, right? So I've used languages that are more structured and I've used languages that are less structured, right? Is what I would say. And when things are less structured, so scheme is an example where it's trying to be relatively simple in terms of language semantics. And that means that your program is just kind of a big bag of code and your runtime memory is just like a bunch of cons pairs all over the place and whatever. And that's your data structures, right? I think newer schemes have actual contiguous data structures, but either the one we used at that time didn't, or
Well, certainly
yeah.
for elegance reasons, you're supposed to just use cons pairs for everything.
Yeah. Yeah. And it's slow and it's hard to debug, right? Because you
Yeah.
don't know what anything is. Um, those are simpler language semantics, but they create a situation that is much harder to deal with day to day as a programmer. And if you're spending a lot of time, debugging, um, that's a really bad thing. And so when I had this compile time execution implemented, the next step was like, okay, there's another technological thing missing here, because I know that if I just say, hey, you can do stuff at compile time whenever you want, there's going to be like a lot of messes. It's going to be very hard to understand in the same way as like, I'm trying to figure out why my cons pairs are malformed in scheme 17 functions down in some random thing that's very far away from the thing that made the data structure, right? And um, so so what I iterated on for a while after that was, okay, how do we create a structured enough environment that the compile time execution is usable, but also uh, is tractable in terms of like not making a huge mess by default. And so there were a bunch of things that were introduced, um, or just the way in which the language treats compile time execution as a feature was like solidified. It like gained, uh, I want to use the word structure again, but this is structure in the layer of ideas and all that, right? And so then we'll come to this specific example you asked about with the static if as a feature, right? Um, so there's a few things about this. Is uh, so why did I want a static if in the first place, right? Obviously, I had to have some motivation, and in programming languages like C++, but other stuff, anything that you would use to make games with, um, needs to have an equivalent of that, because when you target a lot of different platforms. So as you say, you brought up the pointer size example, but there's a lot more pedestrian things. Just like, look, on this platform, the way that you play audio is using this API, and this other platform has no equivalent of that API. You have to do something different. And so
Right.
you have large swaths of code that need to be on one or the other, and you can have those isolated into files. And if you're in C++, then your build system, which is a totally different programming language, might include those files or not. But you still need to like call those functions or not. And trying to shoehorn it all into a uniform interface that works everywhere is not that smart. And so typically you will have these, statically evaluated if statements that'll bring this code in or not, depending on what you're trying to do. So that was the motivation. And then, okay, so first off, there's just a fundamental. Well, no, let's do that second. Let me finish what I was saying about the
Sure.
compile time execution. Um, so if the way that you were providing this feature was going to be, okay, you have a normal if statement, because we're trying to be orthogonal, but that's sort of the context of this question that we should make clear, is like, the language that I demoed has two kinds of if statements. There's the runtime if
Right.
statement and the compile time if statement, right? And it's like, okay, you could, to value this orthogonality principle of language design, you could try to make those one feature,
Mm-hmm.
right? And then your language would be simpler with all the benefits that come with simplicity, right? But this is a case where I did not see how it wouldn't become more complicated instead of simpler, because so you can have an if statement, and then you could put like a run statement or whatever, and then a an expression, right? And I mean, okay, hold on. I guess now that I'm thinking about this feature, it's not even strictly necessary to do the execution in the expression clause of the if, which is the thing I thought of when you said that, because when you do a static if, you normally wouldn't do that, right? You'd have some set of variables that are visible to the whole program that are decided maybe at the beginning of compilation, maybe from the outside of compilation they're passed in, right? And then you would use those, and you wouldn't want to do a lot of execution every time. It's just you did it once and you stored the value in that variable, and like that's easier for people to understand, and it's also more efficient because you're not kicking off all these executions. Um, but let me, just to tie up the previous thing, I'll just say if you were doing it in such a way that you were invoking all these executions, then first of all, you have a lot of executions that makes compile time take longer. But secondly, you do have this sort of thing now where you've got a body of a function, and this is a runtime function, right? We build it at compile time, but we don't execute it at compile time. We execute it at runtime. And then in there, you've got stuff that executes at compile time, which in principle is not that confusing if they're like really tiny and obvious, but code has a way of growing sometimes. So over time, things get big, and then you might be looking at the function and be like, I don't know what. One of the things that I was trying to develop early in the development of the language was like hygiene around compile time execution. Like, if there's code and data structures that are only going to execute at compile time, how do you like not pollute the rest of your program with them and all that? And the more that you embed tiny snippets of things, the more you kind of are breaking down that hygiene, because if you're following normal programming language scoping rules, this little thing that's executing at compile time wants to see all the variables in the scope where it's textually is, probably, right? I don't know. I mean, that's a decision you can make, but
Yeah.
without that, you have to decide where do the variables come from and whatever. And so the longer that body becomes, like the more the compile time and runtime are intermixing, and that's not great. But then to go back to this, so this constant expression evaluation example that you bring up is exactly what I wanted to say is the second thing, which is the following. So to make this work without an explicit compile time if, we've got a runtime if, but you could have a constant in there that's either, maybe it was generated by execution at compile time, or maybe you just typed if one or whatever, right? Who knows? Or maybe you put a variable, or maybe in the case that you're talking about, you actually have some function that looks like a normal function, but it evaluates to a constant under all conditions.
Mm-hmm.
And then I guess what you're saying is you would just automatically pre-evaluate that.
Right.
And you would know that it's constant, right? Yeah. So there is an element of magic behavior in there, which is because remember, you're going between operating systems. So like the code has to not even compile. And this is important for people to understand. It's not enough to be a normal if statement and just not run the code. It's like we have to not even try to compile the code, because it won't compile if you do the wrong branch of the if, right? And so there would be a magic thing that says if there's an if and then a constant, then you don't even compile the other thing, right? And there's depending on the programmer culture, that might be more or less surprising in different ways. So one thing that's not great about that, and again, anytime I say one thing that's not great about that, it's not me arguing that it's the wrong decision in the end, right? Because again, everything's a cost benefit analysis. So like, look, if this is a disadvantage to that thing, if we perceive that the advantages outweigh the disadvantage, it still means the thing is okay, right? But so one, that function that you mentioned that evaluates to a constant could of course be arbitrarily complex, or have callees that also evaluate to constants and whatever. And you can end up in a situation where somebody edits something and it's no longer a constant, and then that propagates. And now this if statement that's very far from the site of the edit um, now fails to compile because it's no longer constant, and so the magic thing doesn't kick in, and so the code for the other operating system that you didn't want tries to compile. And because if is a very general construct, it's then hard to give good error message information about this, right? Because
Yeah.
and this is one thing about orthogonality. Orthogonality means that features are very general, but the more general something is, then the less the compiler knows what you might have been trying to do when something goes wrong. And that means the error messages are worse. And error messages are the user interface of your compiler, actually, right? And you want them to be good. So that's one thing. And then the other thing is like the converse of that, which is if I'm maintaining code uh, for a bunch of different like use cases, right? Like let's say I'm not doing different operating systems, but I'm building on Windows, and during development, um, in our game, we load graphical assets in a certain way because we want them to be flexible. Like the artists edit stuff in Photoshop and then they export it out, but that has to be certain things have to be done on that for it to be good on the GPU and all this, right? And so the game in developer mode like looks at that stuff and processes it and whatever. But in release mode, we want everything to be packaged and tight, and we don't want any of this code around that like manipulates assets or anything, right? So that's another example of one of these compile time variables that you would set when you build. It's like we have a separate executable for developers and the final release.
Right.
And here's the thing is you maybe don't build the final release that much, but when you do, you really want it to work. And then if you have magic if statements that don't even build the code in the other clause all the time, then code can rot under those conditions when you didn't want it to rot. It's like, wait, look, I wanted this code to still get compiled. I just didn't want to call it right now, right?
Mm-hmm.
And so that feature, that ability to know whether this code is breaking or not when it's not actively being used, is diminished to some degree. But again, these are all ingredients in the soup of like what's your cost benefit analysis. And then as someone designing a language, you get to decide what do you value out of these things. And so for me, to finally get back to the final answer, it's just like I liked the clarity of saying that something is a compile time if. It's very readable. We didn't even mention that, but like you read the code and you can just tell like there's a hash mark there that means it's compile time. And so it's very obvious to programmers. You can, of course, if you have an IDE that like is really good at understanding everything about your language, you could like highlight it a certain way or something. But again, those break down, they're slow, they don't work if you're not using them and all these things. And so I just valued that a lot. And yeah, there's lots of smaller things also. We've talked about that enough, I think.
Yeah, sure.
We didn't even,
I
okay, wait. So the second question was related, I guess, but
well,
let's,
yeah, well,
sounds like you have
before we move on to that, so I think a good way to think about the whole, like, what is the goal of your language is that sort of what are you working backwards from trying to have created? So if your goal was like, at the end of the day, I want to say, I made this beautifully elegant language and it's really semantically wonderful and I have, it's a very orthogonal. Or is the goal to say, I am trying to create an experience for the people who are using this language, and I want them to be able to accomplish certain goals with it, and I want them to have a certain experience while they're accomplishing those goals. You're working backwards from two different goal states. And so if your goal is like, I want people to have a good experience, and then I want them to make high quality, high performing games, then you just have a different set of goals. And like, if the orthogonality turns out to help that, which in some cases it will, then it makes sense to go for it. And if it's hurting that goal, then that comes second, because that's not the main goal you're going for. Makes sense to me.
Yeah, totally. And in my case, I was motivated by the fact that I was using C++ and I was depressed every day by C++. And so like I have a rich source of emotion that drives my decision on these features. Right.
Well, this is
And
relatable to me
that's
because
a large amount of context that's hard to explain.
Sure. Well, I mean, and like I have not done any professional C++, and the last time I used it was, I don't know, 20 years ago or something. Um, but I mean, you can imagine, like, since part of my career was doing JavaScript, yeah, like I'm familiar with the frustration of having, like, being stuck with this monoculture where like everybody in that industry is using that language and you're not happy with it and you want to be able to use something better. Um, which in my case, I was fortunate that somebody else made a programming language called Elm, which I got to use instead of that for a bigger chunk of my career later. Um, but yeah, it seems like in the games industry, there remains a very strong C++ monoculture, so that makes sense.
So you had this other question that was about
Yes.
cross compiling. I'm not sure I remember exactly the focus
Yeah.
of the
Well, so
question.
this is kind of again getting back to the boundary. So, like for
Like, how do
example,
you
like
deal with it generally? Or yeah,
well, also just like, one of the things you could choose to do is you could say, okay, we're going to limit what you can do at compile time. For example, I actually don't know the answer to this question is like, do you allow like libc access
yeah,
when you're doing the compile time metaprogramming? Do you allow people to like load dilibs? I assume so, since you're doing audio. That's probably a requirement. And all of those things are potentially things where if you build the same exact source code, on one machine versus on a different machine, you might get different things happening at compile time.
yeah. So determinism in general is a topic that uh, is very important, I think. Not even at compile time. I mean, there's obvious reasons why you want your compiler output to be the same all the time. But even if I'm just making a video game and working on it, I want it to be deterministic because, if I'm debugging stuff, um, and if I'm debugging stuff and the outcome of a certain set of inputs just keeps changing, it makes it tremendously harder to debug. It makes it harder to ensure that what you're delivering to people is something that they're going to enjoy and all this, right? And so determinism, broadly speaking, is very important. But we already kind of handle this, like, obviously in a runtime systems language executable, you can do all sorts of things that are not deterministic. And there's actually nothing, even on the same machine. Like if let's say, for example, I put things in a hash table using the value of the pointer, like as the key, right?
Yep.
Um, that's due to address space layout randomization and all sorts of other things. From run to run on the same machine, that'll give me different. So the point, I add stuff to the hash table, and then I'm going to iterate over the hash table left to right, just in whatever order the things come up, right? They're going to come up in different orders on different runs on the same system on the same day, right?
Yep.
Um, two consecutive runs will be different. And so there just are these issues already. And so here again, here's an aesthetic choice that you have as a language designer is like, to what degree am I going to try to insulate against these things, right? And there's a trade-off, right, of how much functionality can be provided, obviously. And what I said was like, look, yes, I do think determinism is important. I think it's not a good idea to break determinism. Um, but you it's sort of your job as the programmer not to do things that break determinism if you value determinism, right? And so that is going to result in some number of problems that people have, because that's just the way code is. Like I have problems in my games where I would like this to be deterministic, but it isn't, and I have to spend some time debugging why, and it turns
Yeah.
out there's something, right? So here's another example, actually simpler than the hash table example. As we go into the future, right, computers have more and more cores, and you need to be more and more parallel. And so, like, if you just do 8 things in parallel and collect the results into a list, they're
Right.
going to be in. That's the definition of parallelism. Is they're going to be in a different order every time, unless you have a way to sort it afterwards or something, right? And so that's non-determinism, right?
Yep.
And so, like, wait, do you? And so if you have a very iron fist philosophy about this, I'm going to prevent literally everything at compile time that could interfere with determinism. Do you not let anything happen in parallel, or every time you do allow something to happen in parallel, you have to then have a way to sort a well-defined way to sort the output, or a way to make sure that order of arrival of results doesn't actually matter to the order of the greater compilation. That could be true sometimes. Anyway, all this is just to say I made the decision on in the direction of the most powerful thing in order to collect the data on what can we do, right? This is a science experiment.
Yep.
Let's see what we can do. And then if there's a problem, we'll come back and deal with it, right?
Yeah, so I did go back and watch the talk that you gave where you introduced, like, this is, I guess, before you had started implementing it, where you were just basically talking about the design of this language you were planning on creating. And in that talk, one of the things that you mentioned was that you're designing it to be a language that's for experts. You're not trying to put guardrails on things. You're trying to make it so that experts have the best time possible using this language. And so it makes sense to me that,
Yeah,
on the one hand, you want to include features that will make things less error prone for experts to the degree that you can, but also you want to be unrestricted in terms of like what they're capable of doing with the language. And this seems like it kind of fits with that philosophy. It's like, yeah, there's determinism is valuable and desirable, but to the degree that enforcing and guaranteeing determinism blocks you from doing certain things, I don't want to block you from doing those things. I want to make sure you can, and then give you whatever tools I can to, make your life easier in that context.
totally. Yeah. And then also from the standpoint of contributing to the history of programming languages, right? It's quite possible that this decision that I make about determinism here is the wrong decision, as judged by history, 50 years from now or whatever, right? Maybe that's true, but here's the thing though, is like, we're engineers, right? The definition of an engineer is someone who like figures out how to build good solutions to problems. And so if this is a problem, it doesn't mean there also isn't a solution for that problem. Whereas if you look and say, look, I value determinism and this thing is going to introduce non-determinism. And so I don't like that. So I'm not going to go explore that territory at all. Then you never get the functionality and never give yourself the opportunity to go find then the new structural engineering that helps bring back determinism, from this thing that you need. It's exactly like the structure thing that I mentioned early on in compile time execution. Like, if I had decided, like, if there's just code running all over the place, it's going to be a mess and it's going to be too hard to understand my program. I don't want to do that. That might have been true, but it would have also not given me the opportunity to figure out how to structure compile time execution to be good, right? And so it's a similar thing, I think. I mean, I fully understand the argument in the other direction. But I decided early on, this is just not that type of language, right? So the analogy, if people don't quite understand the issue about determinism, it's like a milder version of an analogy that we could make about memory safety, right? It's like, look, a lot of languages think memory safety is very important, but again, you get to pick what is your philosophy about that. Some languages say, it is my job as a language designer to make it completely impossible for you to ever do anything memory safe, right? And so like Scheme falls into that territory, for example, and so do most functional languages probably do at this point, right? And that's one end of the spectrum. And me over in game land, I'm like, look, yeah, trashing memory is really bad. We don't want that to happen. However, we value our ability to access memory directly for a large list of reasons. And so we don't want to get rid of that. So we need a different approach to not destroying memory, right? And so what we're talking about with determinism is, I think, it has a similar character to that discussion. And what I would say is, like with the memory safety issue, I will tell you that there isn't an absolutely correct answer. It's just, where do you want to be along that spectrum? Now, some people who are very dogmatic about memory safety will say, no, there absolutely is a correct answer. It's that you can't ever do anything memory safe. And I would say to them, what operating system are you going to use, bro? Because there isn't any. that was written that way, and there can't be.
Yeah, so
So yeah,
you know, the
um,
games world is not something that I'm super familiar with. In that, like, the last time I made a game, it was, like, in the 1990s and Visual Basic and was terrible. I'm certainly, like, quite a ways off from
that's how everyone gets started.
the type of stuff you do. Um, but I did see a talk that you gave. Speaking of, I guess we can say Rust. We can just come out and say it. Um, but you were giving a critique of a talk about doing game development in Rust, in which you pointed out something really interesting that I hadn't heard anyone articulate before, which was essentially the approach that they were using. They were using some sort of entity component system, and the basic critique that you had was the way that you are using this is in a way in which you are not getting any help from the borrow checker anymore. Like, to the extent that your code is memory safe, it's because of bounds checking, not because of any compile time stuff. And in that world, you might as well be using any language, and you're going to get the same amount of memory safety, at least for this, very large and important part of your program. Um, that made a lot of sense to me. And also, when I had the conversation with Casey like a year ago, he also said something that really resonated with me and kind of changed my thinking, which was we were talking about memory safety and like languages that do or do not enforce it. And he made the point that I think he used the term like pointer jungle. He's like, look, if you don't make a pointer jungle, lifetimes are not always that hard to figure out. The problem is that the style that's been encouraged for decades is like make a pointer jungle and then be sad when it's hard to work with in terms of your lifetimes. Um, and in our new version of the compiler that we've sort of been rewriting, I don't know, with that philosophy in mind, I suppose. Yeah, can't say we've had zero lifetime issues, but the fact that we're not using a language with static memory safety, I don't think has really been a significant problem for us. It hasn't been like a major source of bugs or memory unsafety in practice, except maybe transiently while we're still building the thing. And then once the thing we're working on is actually done and ready to merge into the code base, I don't know. It seemed to be fine so far in practice.
Yeah, I mean, in general, over the past, let's say 20 to 25 years, systems programming in these established systems programming language has actually been improving as practiced by people at the edge of the field. And here's the thing is, it's not really represented though, like this knowledge that's out there is not really represented in, if you get a book at Barnes and Noble about how to program C++ or whatever, it's not going to tell you the right way to do things, because this is like the shadow community of people who have really, figured out how to make programming easier, right? And so there's all these things about how I used to program in the 90s in C that I wouldn't really do anymore, right? So like the abstraction in C and that C++ inherited is like there's the stack and then the heap, and the heap is where all your dynamically created data goes. And anytime you're gonna create something at runtime, it has to go there, and then you get this pointer jungle by default from that approach. And not only are there disadvantages in terms of you know having to think about all these lifetimes of stuff, right? And not only having to think about them, but then um, like I've got some data structure that's full of arrays and strings that needed dynamic allocation. And now I have to go write my function that destroys the data structure and iterates over all those things and destroys them. And that's something C++ tries to do for you, but it always requires some degree of manual intervention. And you just have to like write all that code as well. And in addition to writing it all and making sure it's correct, um, it's actually slow to have all these things on the heap in different places and all that. And so this is one of the things, one of the reasons why functional languages did not reach nirvana as quickly as they expected to, um, was this idea. So let's go way back in time to to the invention of Lisp, right, when computers were really slow compared to today and really simple compared to today, um, it didn't necessarily seem like that bad of an idea to have all your data structures made out of these cons pairs, because navigating memory was not like materially different from any other things that you might do. And so, it's still, even, by the late 60s, early 70s, I think people knew that was not that efficient. Actually, Casey's history talk that he just gave talks about this a little bit.
Yeah.
But it still wasn't like, it wasn't orders of magnitude less efficient unless you had really, really big data structures,
Did
right?
they have like, I
Um,
don't know if in the 1950s did they have like CPU cache hierarchies? Like, what was there an L1 cache, to get misses on at the time?
I mean, here's the problem is there were so many different things being experimented with in the early days that, uh, if I say like, well, caches didn't exist till such and such a time, which I don't even really remember, somebody will be like, "Nuh-uh, the Burroughs P17Z, which was only created in a limited edition of 3 for a secret branch of the U.S. government, had a cache or whatever." And you're like,
Right.
yeah. Um, so I am not, that history area is definitely not my strong suit. It's not where all my knowledge goes. I spend most of my time fighting with software today.
Yeah.
Uh, but the point being, generally speaking, as computers have evolved, CPUs got faster tremendously, and memory also got faster, but it didn't get faster as fast as CPUs got faster. And when you compound that effect over, uh, well, and then also memory got tremendously larger, which is one of the reasons why it's not that fast, right? Like the cache on your CPU is both quite fast, and your L1 cache is way bigger than any RAM that anyone had back in the day, right? But you also need gigabytes or hundreds of gigabytes now, right? Of main memory. So um just we're in an environment that people didn't envision, and I remember this too. So when I was in college, from 1989 to like 95, I used a number of functional languages, and they all had garbage collectors. And um the vision was that uh garbage collection was essentially going to become a negligible part of the computational budget of these programs, just because things, computers keep getting faster. And in retrospect, there's something missing from that logic, because if the computers are faster, they're running your actual logic faster as well. So like the proportion of garbage collection time to non-garbage collection logic time wouldn't like change. And you would always want the garbage collector to be minimized, right? Now, since then, there have been a number of technological improvements in garbage collectors. They're actually faster since then, but everybody envisioned that they would be a complete non-issue by now, that this memory thing, like, nobody
Right.
was going to care about the speed that you pay for this memory safety, right? And it turned out not to be true. And the reason is just the evolution of CPUs is that memory is now very slow, and the CPU core, its ability to process instructions, is now very fast. And if that had gone the other way, then programs would look very different, and uh, the ideal programming language would look very different.
And I think there's another component to that, which is on the one hand, the garbage collector is certainly responsible for some of the slowness, but there's other compounding factors on top of that. Like, for example, like in Casey's performance aware programming course, like the first thing that he does is he demonstrates a for loop in Python that sums up like a million integers or something. And then he goes through and like shows different ways to optimize that in C until he gets it till it's like 10,000 times faster. And a lot of what's happening there is he goes through in a debugger and he steps through. He's like, here's all the stuff that Python is doing at runtime to execute this for loop compared to what C is doing. And a lot of that has nothing to do with garbage collection. It's just things like deciding that you got to box all your integers on the heap, and make them objects, which are like a hash map of string with string keys in case you want to do, runtime metaprogramming that way. And I don't know to what extent people thought that that would all be free too, at the time. But certainly it's like obviously the case that if you take something like an integer and you make it like, like literally 100x bigger in memory than it needs to be, or something along those lines, then like, yeah, that those types of costs are going to add up. What if you got a whole array of integers, you know? Um, and I think that, I don't know, those things seem to be coupled in a way that has been unhealthy. Like I think the best modern example of this would be Go or maybe Swift, of like being like, okay, we've got a garbage collector, but also we try to unbox things as much as possible. Like Go has like structs that are just, you know, the same thing as far as I know as C structs. There's no extra overhead. But and Go gets much better performance, generally speaking, than a lot of these, you know, certainly than like Python, for example. So yeah, I think there's a lot of room to, you know, revisit a lot of those assumptions and do a lot better in terms of runtime performance without really sacrificing any ergonomics, as far as I can tell.
Yeah, and again, that was the attitude. So I just mentioned this with respect to memory, but with respect to language speed generally, that was the idea in the 90s, was like, nobody's going to care if you're running an interpreted thing or a compiled thing or whatever, because it's just going to be so fast. And that has turned out not to be true,
Right.
as it happens. Um, and I think it took people, well, some people actually, if I post this on Twitter, I'll get a large amount of people arguing like, no, everything's really fast. I don't know what you're talking about. But
Oh.
actually, most of the software that I use from day to day is quite slow, actually. Um, and like, I think it took people a while to realize, because while this was happening, you don't know where it's going to end up, and it's a new trend and whatever. But at this point, it's like, yeah, these interpreted languages are a lot slower than compiled languages, and it matters. Um, and well, and it matters for more than one reason, right? It matters because of speed. It also matters because like there's more live dependencies in an interpreted thing, and so your environment's changing all the time, and so your program breaks when you change something random on your machine that you thought wasn't going to affect anything, right? um so now we see this trend, and it doesn't appear to be changing anytime soon, because we've been so many decades down the trail of refining the same kind of CPU and whatever, right? And even if you get like a tensor core coprocessor by default or whatever, it's not going to change any of this stuff.
Right.
Um, we kind of know what CPUs are now, um, unless some random, you know, big evolution happens, but it's not clear what that could be. Like, you know, quantum computer, but quantum computers are not actually computers in the way people think about them. They're like specialized circuits to do specific things. And so if we do quantum computing, if we figure that out, what you would expect anytime in the foreseeable future is, again, like a coprocessor that's maybe kind of like an FPGA, or like the early GPUs. So early GPUs were not programmable in the way that they are now. They were like, here's some stages of computation that are set up, and you can like flip some little gates in there to make different things happen on the screen, and it's baked in, right? And quantum computing is like inherently that way. So I don't foresee any of this changing at this point until we're so far in the future that nobody knows what's going on.
Right. Well, unfortunately, it seems like the current direction is that, yeah, like you said, hardware is getting faster by making things more parallel, but software is getting slower in a way where parallelism doesn't help. And a lot of the problem gets back to something you kind of mentioned in passing earlier, which is like the number of layers that are stacked on top of each other to get your software to actually do anything with the hardware. Like I we mentioned very briefly before we started talking about, like, I work at Zed. We make a code editor that's written in Rust, and there's this very like direct to the GPU, write the shaders yourself, blah blah blah, kind of like game programmer kind of mentality for designing that thing. But by far the most common way to make an editor is using Electron, which is basically like, and actually I would bet a lot of the people who are using Electron are using it with React and then maybe a React framework on top of that. So you're like, we got my React framework, which is talking to the React layer, which is talking to JavaScript, which is running in a virtual machine on top of Chrome. But then on top of that, we're not even accounting for the entire operating system. Like Casey had a talk, it was like a 30 million line of code problem or something like that, where he talks about like back in the Amiga days, OSs were so trivial and thin that everyone would write them as a matter of course while you were writing your program. And that was easy because they weren't doing that much. Modern operating systems are doing a huge amount of stuff, you know, even when you get down to that level. So it's like the number of layers, each of which is adding slowness on top of the hardware, is it seems like it's continuing to expand in a way that's like pretty frustrating.
Yeah, and it's non-linear in the bad direction as well, right? Because layers are added over time, right? So that's one, linear factor. And then each layer itself uh gets like more for loop iterations in it or whatever. And so that's another factor. And so it's kind of quadratic, or the exponent is greater than one for sure. Um yeah.
Yeah.
I had a talk at one point that was never public where I do a bunch of math based on this, and I run like a simulator that shows expected future slowdown based on if you
Huh.
juggle around the factors of what you expect software growth to look like. Um, yeah, I don't know. I mean, well, so the thing that's heartening is actually, in the past couple of years, it seems like there's been a renaissance of people who actually notice this and care about it and would like it to be better, which is refreshing, honestly, because if you go back 10 years ago, I was saying all this stuff and Casey was, and a couple other people were, but like there was not that many people who really cared and were well, there's a combination of like caring, but also being competent and active enough to actualize that caring in terms of results in the real world, right?
Right.
And there was an extreme lack of that 10 years ago. But now it seems like there's a bunch of people like doing stuff. And, um, the results are so obvious at this point. So there was, going back to Casey for a second, there was the Windows terminal kerfuffle that
Oh
happened a few
yes.
years ago where I don't know if you saw this, but some people on the team, he was saying that Windows terminal was very slow, and some people on the team were very internet aggressive toward him. And so he just spent a couple of weekends like writing a terminal, and it was like orders of magnitude faster than theirs. I mean, non-production ready, but proof of concept thing. And just like that's the thing about computers is they're objective in a certain way. And like if the code is running and doing a thing, it's kind of undeniable that it's running and doing that thing, right? And you can't, it's not rhetoric anymore. It's like, look, this is a thing. And so there's been, but since then there's been some programs that are like better examples of that. So there's File Pilot, for example. I don't know if you've used that. Uh, it's a file manager that you can run on Windows. It's made by one guy, right? It's not, how many people work on, Microsoft's terrible, file explorer or whatever it's called. Like I'm sure a lot. But so you have one guy, he's making this program. It's way snappier than the Windows one. It's much more responsive and fast and feels better to use, but it's also more functional. So like things like searching for files and narrowing down, like I want a file in this folder with a substring or whatever. It's just a lot more natural. So like the UI design that he's doing is way better than the UI design that Microsoft is doing and all this stuff. And it's, you use it and you're just like, oh, this is just fundamentally better software than any of these other things. And all these arguments that people have, like, oh, file manager has to use all the standard widgets. And there's like 30 or 40 different folder icons on the screen. That's obviously inherently very slow. And it's like, no, you have no idea how fast computers are now, you know? And anyone who uses Windows, I recommend checking out File Pilot.
I would also recommend for terminal emulators that are actually good, Ghosty. Although I don't know if Ghosty is available on Windows. I think it might just be Linux and Mac at the moment. But yeah, it's a very high quality terminal emulator that's very fast, and it doesn't have any of those problems. A criticism that I've heard of you and Casey, which I don't think is valid, is sort of like, well, these guys are just throwing stones and they're just criticizing everybody, and but like Casey went and made the terminal, and then a lot of people, I think he used the term, there was a parade of excuses as to like, well, but you didn't do this or that, and then he spent another weekend
Yeah.
and did like the top 10 things that people most commonly said would have would have caused it to be slow if he'd implemented them. He's like, oh, look, I'm not going to go all the way to implement the whole terminal, but like I wasn't kidding when I said these are not the reasons. It's just you didn't do it right. And then similarly, I mean, you're very critical of like C++ compile times and things like that, and you're walking the walk, and you're making your own thing, and actually you've built now a 300,000 line, you know, game, like commercial game that you're going to ship and, you know, sell for money using that thing. That's not just throwing stones. And I appreciate your point about, you know, it's really easy for people to say, like, nod along and say like, oh yeah, I agree with that, and then not to take any action. But I agree, it is heartening to see that even if we're not in the majority, there is a pretty large group of us who are actually genuinely trying to go make like high quality, fast running software in the world. Which yeah, didn't seem to used to be like a movement at all.
Yeah. Well, it's very weird because, you know, whenever you go see one of these things that have been around forever about like, here's how you should program, here's a book about how you should program or whatever. The reason why you're supposed to follow this methodology is because the outcome is good if you do this and the outcome is bad if you don't do it, right? Now, any even remotely scientific or engineering oriented discipline would then be actually measuring whether the outcome is good or not of doing these things. And in
Right.
software, we just don't. And I get it because part of it is just it's so hard. It takes a long time to build these things, right? Um, and you know, so it's not like you can A/B test building something twice because like you're 20 years older at that point or whatever.
Yeah.
And well, now that's the case. It didn't used to be the case. Um, and so like it's hard to do this kind of objective evaluation of these things, but we do have in some sense, and maybe it's not surprising because we're human beings, but we have like the opposite of that, which is just this religious, you know, out othering and outcasting of people who disagree with the thing. And it's like, no, if I disagree with the thing, it's because I take issue with the actual objective results that are being generated. And I believe or have demonstrated that I can generate better results. And then, you know, but then there's always some excuse along a non-measurable axis, right? So like you demonstrate, hey, I can make this program run 100 times faster than the one that you built this certain way. And they're like, oh, but then when you add people to your team, they're going to be confused about the code and not understand it. And that's actually a non-testable assertion, but people always go to those because they want to just buffet their side of the argument, right?
Right.
Um, and the thing is, you know, then arguments spiral into these untestable territories. But like, I think when you do all these abstruse, complicated, object-oriented things, the code's actually much harder to understand, right? And
Yeah.
people get responsibility over smaller and smaller pieces of software, which makes them less productive and all these things. But we should be a lot more concerned as an industry with just looking at how good is the thing that we made, how
Right.
good actually is it compared to how good it could be, and just nobody seems to. And a lot of the time, this also gets poo-pooed as merely a performance concern. And we've talked about performance a bunch, but performance is one dimension of this, but there are other dimensions of it. Like, does this software work well? Like the Windows
Right.
File Explorer has all sorts of just crashes now and like bad behavior that didn't even used to be in there. And it's degrading over time. And like, do people not notice that this thing is degrading over time? Like, what's going on? Why don't we just like open our eyes and look at that? And we just don't seem to be doing this.
Right. Quality is in a lot of cases about performance. I mean, that is a very important metric of quality, but yeah, also like, does it work well? Is it easy to use? Is it, you have a nice experience using it? You know, there's a lot of ingredients that go into that. Um, you mentioned people doing like smaller and smaller pieces of work, and that does get into something I wanted to like jump a little bit back to like build time determinism. And you mentioned this briefly in the talk, but you were critical of sort of what I'm going to call the NPM philosophy, where you just have lots and lots of dependencies. Those dependencies have lots of other dependencies. So I know that in the games industry, it's pretty normal to just basically what we call vendor everything. You just download it all, put it in source control, and that's it. Now you have that snapshot, and then, you know, if you want to upgrade it, well, go find a new version.
Why is that the name for that?
The only reason I know about that as a term was just like, I don't know, maybe like 15 years ago or something. I was working at a job where there was a directory in source control called vendor, and it was for stuff that we had forked, and they're like, oh, that's vendoring it. That's the term. I don't know why that's the term, but it seems to be the accepted one.
All right.
The ergonomics of being able to say, like, look, here are my dependencies, just have a solver that solves that for me and things like that. There are some nice things to that. The solution that I've settled on for my language is that there's only one way to get dependencies remotely, which is you have to put in a URL. The URL has to be in a specific form, which is that it has to end with a hash of the contents of what's in the URL. And we also use the URLs for doing version resolution. Like there's also a component of the URL that's like a version number. And so we can solve based on like, okay, this thing says it needs, at least this version. And, we can get within that major version range and stuff like that. So that's the sort of convenience part. Also, that's all like downloaded and cached on your machine. But then also we want to have a CLI command that's basically just like vendor it, which is just like, I specified it in terms of URLs, but I can just bring it all into source control again as a convenience. So it would be very easy to do it either the game developer way or the not quite all the downsides of NPM, but definitely some of the downsides of NPM way. So I use that as an example to I'm curious what your thoughts are on like, would you even say that like that is just like, no, just vendor everything, like you're being silly? Or would you say like, well, maybe that's okay, but like not the trade-off you would choose? Or like, how do you think about, versioning at that level?
Well, there's a few different dimensions here, right? From the standpoint of understanding the dependencies of your program. Obviously, if they're all hidden away and automatically recursed into and like pulled down into a folder where you never look and all these things, it doesn't prevent you from understanding the dependencies, but it's a workflow that does not encourage active criticism of dependencies, which again, a particular designer may or may not think that that's very important. It's an attribute of this, right? That's all. I'm just mentioning that. But then in terms of some of these other things, I mean, again, obviously I don't have experience using your system. I think it's a good idea. Like, okay, you put a hash in there. That way, if something changes, I guess, is that a build error?
Usually if you're rebuilding, we're not even going to go to the URL because it's like you got it on your system anyway. So like this is just like the first time you're on like a new machine, and like that's how it gets onto your machine. If we go to the URL, we download it, and it doesn't match. So it's a build error.
Yeah. So from that standpoint, I mean that solves a particular problem, right? And so like I was saying, it's like, all right, we observe what the problems are with doing a certain thing. Let's introduce some solutions. A hash, represents the fact that this file hasn't changed since I chose it to be the version that I'm working with, right?
Right.
And so if you're going to do that, why not have it on your hard drive? Like, why introduce the point of failure dependency of like, my internet isn't working, or, we just started World War III and the internet is down for cybersecurity purposes. Or anything like that, right? Now I can't compile my program. Like, why, right? So that's and that might be just a fundamental cultural difference. I think web people are much more blasé about, or they don't even understand this concept, maybe, that like you should be able to compile a program later without updating anything, because if you're going to interface with someone else's web API and they changed it 17 times since last time you ran this thing, then you just have to change your program, right? There's like no way around it. And that's true, but I think it's also a toxicity that's affecting software broadly speaking, and it's counter to the culture that I come from, right? So the last game I shipped was this game called The Witness. I have it on a hard drive over here. We last shipped it in, we shipped it in 2016, and we did some minor patching and stuff since then, but like a long time ago in computer terms. And like, I can just whip it out right now on a machine that has no internet and compile it and run the game.
Yeah.
And that's great. It's like the software isn't decaying. I built this thing that exists, right? And this is something I talked about a little bit in the LambdaCon talk, which is like one of the amazing things about software, and one of the aesthetics that functional languages speak directly to, is that your program is a mathematical statement of some piece of functionality, and being a mathematical statement means that like it exists in some platonic realm where the output is determined, right? we talked about
Yes.
non-determinism and all that, but like if you include the potential non-determinism in the statement of what the object means, right, then it encompasses that. Um, and that's part of the beauty of software in some way. And we've somehow adopted this culture where we're just denigrating that aspect of it, or at least ignoring it, right? And I don't like that. I think that's really bad. And so, from that standpoint, I mentioned a lot of a lot of my decision making for what I want in my language is emotional in nature, right? And so, um, one of those is just like, look, I want my software to compile 10 years from now on an island when I have no internet.
To me, part of the case for doing it with URLs is about actually like version resolution and making it more ergonomic to do like upgrades and stuff like that. Okay, let's say I have, 5 different dependencies and they kind of depend on like a third thing that's like, I don't know, compression library or something. And they depend on like maybe different major versions or maybe different minor versions. And I want to upgrade that dependency because there's a performance boost. How do I make sure that they're like, selecting the right things? In my experience, like having a build system that can have like a universal name for all these things that everyone agrees on, like a URL, just makes it easier to automate that like upgrade process. I'm assuming that's the thing that people deal with in the games world, and it's fine. So you would know better than I would what the like how much of a
Yeah,
downside that is.
there's different answers to this. It honestly doesn't come up that often
Hmm.
because in the systems programming world, you can link something and then it becomes like a private symbol that you're not exporting. So like if I use a compiled library, like zlib comes to mind, it's a compression library. It's pretty simple. You might have like 7 versions of it linked into a game, but it doesn't matter because they don't pass data structures back and forth between them. And so it's a little bit of a waste because you have these things in there, but honestly, all that code put together is very small compared to like one bitmap that we would draw off the screen now. So it like doesn't matter, right?
Yeah.
Um, and so, but I don't know. I mean, these solutions are different depending on context. Here's what I'll say is, so for the system you described, there's relatively minor nuances to that system that could push them in one way or another. So you mentioned like, hey, okay, if you check out without building once, then you don't have this source and that's a problem. But you could then, if you wanted to, and obviously this isn't the decision that you made, but you could say, well, the cache, instead of being a hidden thing, as is uh, traditional, it could just be a visible vendor folder and you're supposed to put that in source control with everything else, right?
Right.
And then it's still the same system, but it's like it's a different result. And of course, whether you think that's a good idea or not depends on how much how much stuff you think is going to be in there, and whether there's large binary data in there and whatever, and all these things. Um, what I will say is, I'm coming at this slowly from the other side, which is, um, I'm going to put air quotes around vendor just because that word is weird to me. But, that's the approach that we take and that we recommend people do, is that if you're going to depend on external things, it should be in a folder that you check in with your rest of your source. Um, we don't currently provide one of these automated, dependency package manager situations. However, I have been designing our system such that such a thing is possible and uh, creatable in user space again. Like all the stuff I showed at LambdaConf. Um, you could create a package manager for this programming language that's just runs in compile time execution and like does the thing, right? So what I'm hoping is that if such a thing is created, because I don't see that as being my job right now.
Yeah.
Um, it would be in line with this culture of having dependencies explicitly in source, and so it would just be layered onto that and put things there visibly. But somebody could do the invisible cache version if they wanted. I don't know.
Well, of course, I
Yeah.
mean, what a lot of people will do, I would predict, like once such a thing exists, is that they'll do it, it'll go into a local folder, and then they'll just put it in, ignore it in the source control. Right? That's a super common thing in the JavaScript world. Um, Yeah, I don't know. I definitely buy the argument for like the simplicity of just having that be the only way to do it, especially the point you just made about it's a way to get visibility into the size of your dependencies and like what else they're bringing in and things like that. Is like if it's all in your source control, then it's a lot more obvious when that thing is getting out of control than it is when it's just like, well, I've got, you know, 80 lines in my dependency list instead of, 20 lines. And no, that's not that many more lines, but it's a lot more lines of code. And yeah, there's an
Yeah,
incentive difference there.
I also think we've been living in a relatively peaceful time. And so some decisions make sense that may not make sense in other times. So again, in case of like serious war, you might shut down the internet. But there's other things that may happen. So we've been seeing a lot of this like in games lately is there's right now as we speak, there's going on a big controversy where payment processors don't like certain kinds of games and are
Mm,
now muscling in and getting stores to take down those games essentially, right?
yeah.
When it's actually a very tenuous connection. Like, why would the payment processor care about this thing? Whatever. But it's like somebody somewhere has an agenda that is bubbling up to this, right? And what that means is like, look, if I have a game on Steam, I can't guarantee that I'll be able to download that game later, right? And so the same is true with software, right? Certain things are currently legal uh, that may become, especially AI related things, let's say, uh, also maybe encryption related things, also maybe, blockchain related things, different kind of encryption related thing. Um, all of these things, you can imagine a future in which there are just takedowns of these dependencies because the environment has evolved enough that somebody somewhere in the world doesn't like them and is willing to enforce this, right? And so again, that's a hypothetical. Maybe that won't happen, but like I've already seen enough of it that I'm not comfortable with I'm not comfortable with assuming that that's not going to happen.
Well, and
And
even
so, obviously if that happens, you can rewrite that part of your program or
yeah.
whatever.
Yeah, but I
It's
mean,
just a
like
headache.
another example of that, which is, I mean, it's less of an emergency. Like suddenly these are all gone, but like something that I can certainly imagine causing a lot of problems for people is that a whole lot of dependencies are specifically hosted on GitHub, and a whole lot of those are specifically hosted by people who are not paying anything for that. If Microsoft got in financial trouble and they said, hey, we're not going to give this away for free anymore. If you want to host your
Yeah.
dependencies here, it
Yeah.
costs money. And suddenly people are like, nope, yeah, shutting that down. I don't want to pay for that. All of a sudden, none of your URLs are resolving anymore because Microsoft's not paying for it and the person who was originally doing it's not paying for it. That wouldn't be
All
as
sorts of
much of a,
things.
yeah.
No, I mean there's many variants of this that could happen, right? And each one of them is not necessarily that high of a probability, but you add all those or you productize all those probabilities together
Yeah.
and it's maybe not that low. So like another one, like let's just say maybe there's not like a big war, but it's like for tensions escalate with China and the US decides that it's a security issue if any software package has had Chinese nationals checking in changes to it, right? And by fiat of the federal government prevents those things from being downloaded, right? That's a lot of things, right?
For
And
sure.
so, um, you know, I don't think that specific thing will happen because in practice, that's basically all software at this point, and so you would be banning all software, but you can imagine someone just getting picky about particular things or whatever. Like this person we've decided is sensitive contributed to these things. So who knows? I'm just saying, I think we've been in a relatively cushy, relaxed time with respect to how the internet is, and that might change. It might not.
That's fair. So going back to garbage collection earlier, one of the things you said at the talk that stuck with me because it's just such an unusual thing to see was you're aware that you're talking about a systems language with manual memory management to an audience full of functional programmers, and you basically said like, well, let me sort of like defend my choice of making a systems language with manual memory management to an audience that's like, obviously like defaulting to the opposite of that. The reason that resonated with me is I feel the reverse whenever I'm talking to somebody who's really hardcore about performance, like you or Casey, where I'm like, well, let me defend my choice of making a language with automatic memory management because I care about performance and want things to go fast, but like I also think that this has value. In your ideal world, is it that like everybody uses manual memory management for everything and knows how to do it well and creates the highest possible quality software? Or do you think there's a world where there is room for someone to make software that's like a high enough quality that you kind of can't tell the difference? Obviously, this is not going to work in like a super high performance game, but there's lots of other software that we use all the time. But like, I'm just kind of curious, like on a philosophy level, like how do you think about like, was garbage collection just a
Yeah.
mistake, or is there room for it in the world?
Well, I am not absolutist about this. I am not at all a person who says there should not be garbage collection. And there's one form of thought pattern or argumentation that I like to use about all these things, which is find the point at which it's obviously not the case, and then look at where I am. And the real point for this decision about should you use garbage collection is somewhere in the middle. And maybe there's arguments about where in the middle that point is, but it's just an argument about where to turn the knob,
Mm-hmm.
right? So, which is then automatically not really a religious argument anymore, because
Right.
religious arguments are all like things should be or things should not be or it should be the best. So for example, there are a lot of people, and this is not to denigrate garbage collection in any way. This is me going all the way to the other end of the spectrum, right? To
Sure.
find this point. And ignore the fact that LLMs are becoming a thing now and people are using those for programming, because this is an argument that goes back a few years, but it's just like, look, there's all sorts of people who are not professional programmers. Professional programming is hard. There's a lot to know. It's very difficult to put these systems together, but there's lots of cases in which you want some programmability for, like, I don't know, like the guy's runs a store and he wants to control what is on the sign that is now run by a computer or whatever, right?
Sure.
Or you could think of all these things. There's a scientist in a lab who's like a chemist and he doesn't really know how to program, but he wants to do some data analyses or some visualizations or whatever, right? So there's all these categories where obviously if you say you should be as hardcore as a professional programmer, no, chemistry dude wants to do chemistry research. He's shouldn't
Sure.
have to, right? And so there's this aspect of like on that end of the spectrum, it's about bring the functionality of computers to that person, and probably, uh, you know, a garbage collected language is the most appropriate thing for those contexts, right? Um, Now on my end, for what I do, I really don't want garbage collection. In video games, one thing that happens is people make games in C sharp, which is a garbage collected language. And they do that because they perceive that it will be easier. Whether it actually is or not, who knows? That's a different argument, but they perceive that. And because common popular game engine Unity, that's the main way to write code if you're using Unity, is to do some C sharp stuff, right? So, but a classic thing that happens is you start your game and you're like, oh, this is really fast. My game is small and simple. Garbage collection is not going to be a problem. And then it ends up being a problem by the time you're trying to ship, because in games, it's very tangible. Like the frame rate will start to stutter, right, in unpredictable ways.
Yeah.
And so then there's all these things like, hey, just pool all your objects and all these things and do all this manual memory management and reduce load on the garbage collector, right? And that's true that helps, but that's all the stuff you would have done if you were manually managing memory anyway. But then also you end up in this frustrating position with some of these systems where you can't really control, like you can reduce garbage collection in a limited amount of your own code, right? But at some point that becomes infeasible. And then also you're using third-party libraries that are generating garbage in a way that you can't control. And some of them may be quite aggressive about generating garbage, right? And so you end up in this place. I've seen a lot of games end up in an unhappy place there. Anyway, this is all just to say there's a spectrum, and somewhere along the line of use cases that's not so extreme as like only non-professional programmers, and is also not so extreme as like we need to run at 120 FPS on a small consumer video game console, right? Um, Somewhere in between there, I think there is a garbage collection use case for sure.
That makes sense. I do wonder about within games. The example that immediately comes to mind is Roblox and Luigit. I guess they have their own flavor of Luigit, where I guess the use case is
Yeah.
essentially like you want to be able to run on one player's machine untrusted content from another user, and being able to have a really strong sandbox, which Lua does in addition to being garbage collected, which I think is hard to do if you're not going to be garbage collected. Um, Seems like a selling point unto itself. And that's not just a games use case. That's also like any kind of plugins or extensions for anything. Like if you can have a really reliable sandbox around it, that's a potential selling point.
Yes. Yes, you can to some degree sandbox systems code like that. However, um, as soon as you start doing that, you run into all these issues where like modern operating systems kind of drop the ball at some point and don't really allow you to do things that you wish you would be able to do. So like you would like to create a separate thread or some kind of other memory context and say like, okay, well, if you do write through a pointer to something, you only have write permissions to certain things. And there you go. And that's actually not really possible to do without like creating a separate process. And then once you have another process, communication to that process is like annoying and subject to certain constraints and all these things. And I don't know. That's not I've never gone down the road of engineering that kind of a thing, but this also comes up in like Roblox is an extreme example, right? Where like some 13-year-old kid wrote code that's running on your machine,
Right.
and who knows what that is, right? But you know, even with things, this comes up um, with plugins for just regular programs. So like an editor, right? Um, there's all this stuff, you know, language server protocol stuff that I hate. Um, that was designed for basically two reasons, as far as I can tell. One of the reasons was that the people who do JavaScript and other things back at that time when this was introduced didn't want to ever interface with any systems level thing. And so these traditional ways that you would do plugins, like having a dynamic library that you load that conforms to a known interface, which is how plugins have been done since the 90s, right?
Yeah.
And it's a very fast, highly performant, highly structured, and therefore good at reducing certain kinds of bugs way of doing these things. And one of the reasons why it's good that you don't have with like language server protocol is you can just share data structures across this abstraction boundary the way you can. So you can pass very complex structured data back and forth. You don't have to serialize and deserialize and reparse and look for parse errors in the frickin' thing and all these things that
Right.
happens as soon as you're serializing. Um, so that's how plugins have been done since the 90s. But the problem is, if your plugin authors are not as trusted, it doesn't even have to be like, you know, no level of trust, but just like, I kind of don't trust that this plugin isn't going to crash a lot or whatever, right? And then you're trying to run it, and again, you have to isolate that plugin in a separate process, because if it's in your same process, you kind of can try to recover from an exception in that code, but like it's pretty dicey, and the magnitude of what you can do varies on different operating systems, and there are certain things that are just unrecoverable. So like if another process like uh, acquires a mutex somewhere, or let's not even do that. If there's some common code used by both of you that uses like a lock-free synchronization mechanism where it just like increments an integer that you're supposed to decrement again before leaving the code, and then it crashes, and now you're just screwed. Like everything is just broken, right? And so I think for these reasons, these are things that we could have fixed in systems land if we cared, but at some point, everybody gave up and stopped trying to make serious I don't know, people like decided things were solved and then let them decay. I'm not sure what happened, but there's all these things that we actually don't solve. This is also why containers are a big thing. Like, we used to have a name for a system that would reliably rerun the same program over time. It was called the operating system, right? And like somehow we let the operating system stop doing that, and now people are like, oh, containers, and it's like that used to be the operating system. So now we've got an even bigger mess now, right? There's all these things that systems people, I would say, is their fault. Like, it's their fault for letting things get this messy and effed up. But the supposed solution for these things is like stuff like language server protocol, which has a large number of flaws and is very slow and limited, and also doesn't even really solve the problem. So like, okay, I've got a plugin I'm talking to over LSP and it crashes. And like, if you actually really want to recover from that robustly, it's maybe not as bad as like the lock-free integer case that I mentioned, but like, it can actually be really complicated in your code to like try to recover from this thing stopping responding at arbitrary points anywhere, right?
I also would like for there to be a viable alternative to like language server protocol that doesn't require a server to like do extensions. Obviously that's the most popular thing, but I'm also frustrated that something that has that much overhead is the dominant way that everybody does these things.
Yeah, it's kind of and part of what's going on is like, people don't, like, web programmers have not grown up and may never have seen at all the ability to pass a large sophisticated data structure between code written by you know just running in different processes, even, for example, right?
Yeah.
Or I don't know, whatever, and so it doesn't, when you say, oh, I'm going to serialize this because I'm sending it over the network to this other process on my machine, it makes sense because it's like, oh, that's just like what you do with a web server. And it's like, actually, no, there's something a lot better that you could do, right? And because it's not in that subsector of the programming culture, people aren't bothered by it, I guess. But yeah, I mean, the thing that bothers me more than the inefficiency of all that is, yeah, like, why is nobody working on operating systems now? Right? Like, why are I mean, we essentially have operating system designs that were finalized in the 70s. Either so Windows NT, right? Um, the acronym for that is WNT, which is VMS incremented by one letter. And that's not an accident, right? Like, its design was inspired by the design of VMS, which is an operating system from the 60s and 70s. And then, of course, everything else is Unix, uh, which is also 1970s, right? And
Yep.
so, like, these things have been refined a bit since then, but the fundamental concepts are like literally 55 years old. And like, we kind of haven't progressed those core concepts very much. There have been some things, Rob Pike was trying to do some stuff with Plan 9 that didn't catch on. Again, that was all about serializing and deserializing, so I don't love that. But like, look, he was trying to do a thing there, right? And then, I don't know, we just kind of gave up on operating systems. And then some people might say, oh, that's because it's solved, but it's not solved. Like, we have these very real problems that, like, the reason you can tell is that it's an unsolved problem is when there's kind of like no right answer within the current framework to what should you do. So what should I do if I want a fully robust, untrusted plugin running on my machine with my code? And the only answers you can come up with that are like,
JSON.
some crazy thing like run a web browser embedded in the process, and then run some JavaScript in the web browser, and never mind that JavaScript can break out of its sandbox, in all sorts of ways. Because I mean, the bigger and more complicated the system had to get, because it's the web, the more vulnerabilities you have, right? So yeah, we just don't have a good solution for that. There should be one. Like, I sort of feel like there should be, um, like, systems people should have gotten together and done a thing that is like Java bytecode, but is not married to any particular backend. It's just like, look, it's an abstracted version of machine instructions that just operates on memory. And then if you want a protected memory environment over that and all that, you can do that. If you want it to be garbage collected, you can do that. But at its core, it's just this heavily sandboxed, um, you know, uh, virtual machine that runs the same everywhere. And like, that should be like a standard thing that all operating systems run, and they don't. And there
The
probably were
closest
reasons for that.
that I've heard of that does something like that is WebAssembly, which has a bad name because it's not web specific and it's also not assembly. But it is at least sandboxed, and it doesn't have quite all the properties of like it can run everywhere. But I don't know what the reason was for behind this design decision, but it's very limited by the fact that the smallest integer you're allowed to have there is 32 bits. I don't know why that was the design, but I don't know. From my perspective, that's like a really surprising design choice for something that's aiming to be, like high performance and portable.
Yeah, I don't know. I mean, I've stayed away from looking at the details of WebAssembly because I'm sure that I would not like them. Um, it's shocking to me how long it's taken for WebAssembly to kind of still not really catch on, and maybe it's because it's too complicated for what it is and also has these problems, right? But like, the actual core thing is actually very simple, and a lot of people understand what like, LLVM has LLVM bitcode, which is a version of this. It's very, very complicated because it has to target all these backends and like do all these things. But like, people have seen that, right? My compile any modern compiler really has its own version of this. It's got some kind of imperative, software implemented instructions, because that's just the best way to do things toward the back end that map to CPUs. Some people don't. So like Cliff Click's compiler doesn't have that. I think it's all just like graph theory stuff, and then it outputs code at the very end. But that's an unusual architecture, and most people go to some kind of virtual CPU-esque instructions before outputting code in the back end. So like, we have these all over the place on our computers. It's just we can't like land on one that we all can just use. It's very weird.
Yeah, there's a lot of because the operating system doesn't provide a nice way to do this thing. There's 5 different solutions, and most of them are a lot slower than what they would be if the operating system were able to do it. And then, of course, there's no standard because they all have different
Yeah.
trade-offs. And
Well, what I was going to say is I think this is also not an accident, right? Because the attitude of Apple and Microsoft and everybody else making operating systems has been, they want to trap you on their operating system, right? So like, when they make an API, it's not just to help you do things, it's to help you do things in a way that it would be inconvenient to also do the same thing somewhere else, right? And so, I mean, on rare occasions, they get together and standardize something for which that's not true. But, Microsoft is famous for embrace, extend, and extinguish, which is like, oh, hey, there's some standard. Let's just say somebody did make this standard bytecode. They would be like, well, we're going to add some Microsoft instructions to add value to this, right? And then we'll convince everybody to use the Microsoft only instructions, and et cetera. And so it's really been a field of war out there, right? Which is the place, if open source was really doing its job, to poke at open source for a little bit, open source can be the people who do not have those perverse incentives and can be like, look, we're literally just trying to make the software for the good of humanity, and et cetera. So, they could fight back against that trend, but that hasn't helped. Like, we don't have any of this functionality of which we speak, so that didn't work. I don't know.
Right. Going back to something you said earlier about web development and its influence on the industry, you mentioned a lot of people have no idea that it's possible to share things between, two different pieces of running code in a low overhead way. And earlier in my career, that was me. I had been working in the Java virtual machine, and that was the absolute lowest level thing I'd ever worked in. And then, half the time it was a JavaScript virtual machine or something like that. In that world, there is just a giant knowledge gap around what is possible for the OS to do and for the hardware to do.
Yeah, and the thing is, in the old days, if someone wasn't aware of some basic thing about software, it would kind of be their fault, because it's like, look, you haven't learned the field or whatever. But now it's so complicated, and there's so many different domains, and there's so many different, ways of programming and whatever. You can't fault anyone for not knowing these things, especially, you can work in a 5,000 employee company where everybody just thinks the way that you transmit data is by converting it to JSON, right? Like,
right.
That's just, that's where we are. And so what does that mean? Like, in terms of software quality, I'm not sure. It doesn't feel good, though.
I think about it as like my challenge as a language designer is step one, which is hard enough, is making something that is high quality where you do get a fast feedback loop, and then also the thing that you build does run fast and is easy to make correct, or as easy as we can get it. But then the other part of my job is to try to make it so that it's accessible to that audience.
Yeah. I mean, that's good. I mean, that's language design, right? It's like,
yeah,
let's try and do this thing. Let's try and make an improvement. And who knows how things will work, but yeah.
Yeah. Well, thanks so much for talking about all these things. This has been
a
really,
to you. Thanks for having me.
Yeah, fascinating conversation, and really looking forward to see like your next demo of awesome technology, and best of luck with your game and with your language, and hope it all works out great.
Yeah, good luck to you as well. It's not easy making a programming language unless it's a toy language. Toy languages are fun. I encourage people to get into that, but once you start getting real in the year 2025, it's really complicated, So, yeah.
It is.
Good luck.
Complicated but rewarding. All right. That's it for this one. I hope you liked it. You can find links to some of the things that Jonathan and I talked about in the description. And if you'd like to become a supporter of Software Unscripted, check out patreon.com/softwareunscripted. Until next time.